In the harsh environments of offshore oil production, one cable surpasses all the others: Exane, the premier oil rig cable. This extraordinary multi-purpose cable is used in the most demanding applications and offers unsurpassed reliability. In fact, over 1 billion feet of Exane has been installed in oil rigs around the world without a single field failure being reported. Over the past 25 years, Exane has been the standard of excellence by which all wire and cable products are measured for use in mobile offshore drilling equipment. Recent changes allowed by the U.S. Coast Guard and other regulatory agencies now allow the inclusion of cable built in accordance with IEC 60092-353. These cables are now being touted as a low-cost, low-smoke alternative to IEEE 45 Type P cable. Before specifying IEC cable for use in any mobile offshore drilling equipment, Rockbesto's Serpernaut feels it is important to fully understand how these cable constructions compare with Exane Type P in several critical areas. Standard IEC 60092-353 cable constructions are supplied with the European Conductor Stranding Class 2. This metric size conductor is equivalent to US ASTM Standard Class B. Exane Type P cable is supplied with the more flexible ASTM Class I stranding. The flexibility of the IEC construction is greatly affected by the rigidity of the Class II stranding. In addition, the overall size of the metric conductors vary as compared to standard American wire gauge stranding, causing potential termination problems. The insulation material used in the IEC construction is ethylene propylene rubber. Commonly known as EPR, this material is soft and non-flame retardant. Because of this, a braided metallic armor and overall low-smoke zero-halogen jacket are applied to aid in overall flame performance and as a barrier against mechanical damage. This adds dimension and weight to an already stiff construction. Exane Type P cables are designed to perform in the harsh environment of offshore oil exploration. The Exane single-layer insulation material, combined with the more flexible Class I stranding, provides a cable construction that clearly has superior flexibility, mechanical protection, low temperature protection, and flame performance. To demonstrate the flexibility differences between Exane Type P and an equivalent IEC construction, a 535 MCM Exane construction was wrapped around a prescribed mandrel in accordance with the American Association of Railroads specification RP 585. As you can see, the Exane sample conforms easily to the mandrel. Another flexibility test, developed for transit car wiring, measures the torque in inch-pounds required to bend a sample a specified radius. The 535 MCM Exane sample bends easily 180 degrees. The required torque to accomplish this was 225 inch-pounds. The 300 mm squared IEC construction is so rigid it cannot be bent. The torque required to move the sample peaks out at 600 inch-pounds. Both cable samples were exposed to a cut-through penetration test developed originally for the aerospace industry. The amount of force required to penetrate and short-circuit the sample is measured. Although the Exane sample has deformed, it withstood 2,356 pounds before failing. The IEC sample failed after exposure to only 1,294 pounds. Both samples were conditioned at -40 degrees Celsius and exposed to the IEEE 45 cold impact test. A force of 9 foot-pounds strikes the sample, which is then tested for dielectric breakdown and can exhibit no cracks. The Exane sample passes, while the IEC sample does not. As mentioned earlier, the difference between American wire gauge stranding and metric stranding can cause equivalent IEC constructions to be larger. Note here the difference between an Exane multi-conductor cable and the IEC equivalent when superimposed in a cable tray. Exane Type P is capable of a continuous temperature rating of 125 degrees Celsius, resulting in the potential for increased current capacity. This could allow the end user to further reduce the overall amount of copper used in an installation. Even when derating to the more commonly used 100 degrees Celsius level, Exane offers greater potential for weight and space savings than the equivalent IEC construction, which can only be rated at 90 degrees C maximum. While both the Exane Type P construction and its similar-sized IEC equivalent both pass the IEEE-1202 vertical flame test, you will note some significant differences on how the cables perform. The Exane material has for all intents and purposes self-extinguished 10 minutes into the test. As you can see through this video, the IEC construction remains heavily involved in the fire through the 10-minute mark and continues to burn right up until the flame source is removed. Note also the excessive sparking and melting created by the non-flame retardant EPR primaries. This sparking and melting could aid in spreading a fire further and causing even greater damage. Through these tests, Exane has proven once again that it is the right choice for use in the harsh environment of oil exploration. Superior performance has been the trademark of this wire and cable product since its introduction to the market. For over 25 years, the Exane product line has been the preferred wire and cable for the offshore oil industry. While certain regulatory bodies have loosened the requirements for cable used in this industry, Rockbesto's Serprenant continues to be committed to supplying the premier product for these applications. It is important to note that although the new U.S. Coast Guard regulations allow a manufacturer to self-certify their product against the new IEEE 1580 specification, Rockbesto's Serprenant continues to maintain third-party verification from a nationally recognized test laboratory for the Exane product line. Although the lure of lower-priced cable will always be tempting, the importance of performance of these products cannot be overemphasized. In the harsh environment of offshore oil production, safety is the #1 priority.